Hey, welcome back. It is day 4 of our week 2 coding camp. Today's activity is going to be called Slide Puzzle. I'm here with my campers as per usual. I'll let them go ahead and introduce themselves.
Hello, my name is Keegan Fisher. Hi, I'm McKinley.
You seem asleep today, McKinley. Are you ready to code today?
I guess.
Is it too early for you today? All right, we're ready to go today. So today is called Slide Puzzle, and it's going to start just a little bit different in that I normally show you the solution, but today what I want you to do is I want you to open the solution and play with it. And so the link is clickable there, but I think it's probably easiest if you just kind of look at the real link. So I'm going to make this link available below the video, in the email, also on the website. But worst case scenario, you can look at my screen and type it here. So it's scratch.mit.edu/projects. And then this number is 537-036-624. And this is called Slide Puzzle with Check Solve. All right, so let's go ahead and play this game to learn more about it. So go ahead and hit the green flag. And so what this puzzle is, it's called a slide puzzle. You click on a piece and you make it go into the gap. And your goal is you want to try to get the puzzle to be rearranged properly again. So take a minute and play with it and see if you can make progress towards getting it rearranged. My strategy is I always do the opening row first. You'll notice that each of these tiles has kind of got a number on it, so you'll know when it's right. And then mine's going to actually be pretty easy to solve here, just a couple more. So one more click and I'm going to solve this thing, I can tell. So you'll notice that there's a 3x3 grid, but there's only 8 image tiles present because one has to be gone for the blank. But when you solve it, it should cheer for you loudly as per usual, and then fill in that missing blank. So take a minute and play around with it. You'll notice that whenever you hit the green flag, it'll kind of shuffle around. What we actually want to do first today is we want to show you the game that we're making, which is this game here. But we want to teach you an algorithm for solving it. Also, just kind of like spoiler alert, the goal for today is for you to make your own picture in here. So be thinking about what picture you might want to put in here. It could be a picture like that you took, like with a camera picture. Or it could be just like some image that you enjoy doing. So let's learn an algorithm for trying to solve this thing. So I'm going to go over to the slides here. So the algorithm that we're trying to figure out is how to solve this one row at a time. And so I'm just going to tell you the big picture. So the first few steps are designed to help you get tiles 1, 2, and 3 correct. So that's the focus. Whenever you're working on tiles 1, 2, and 3, you also need the row below it to get ready. This algorithm will work no matter how big the puzzle is, right? So you've got one row you're trying to solve for, and then the row you're kind of working with below it. And ultimately, you're trying to get them 1, 2, and 3 together, but we're going to kind of stage them starting in location 6, which is kind of the opposite corner. So here's the solving strategy we're going to do. Get tile number 1, so this is tile number 1, the one that's got a 1 on it, into location 6. And so you can see we've numbered the locations 1, 2, 3, 4, 5, 6, 7, 8, 9. So we want to get tile 1 into location 6, making sure that tile 2 isn't like stuck in positions 3 or 6. So go ahead and do that. I'll go ahead and do mine as well. So I can see that tile 2 is somewhere way over here, so he's way out of the way, so I'm not even worried about him. And then I'm just going to get tile 1, so this is tile 1 right here, into location 6. Making sure that tile 2 isn't trapped. So tile 2 is not trapped. Trapped would be like, so see how tile 5 here is kind of like trapped up there, and tile 6 it's kind of like trapped down here. So long as tile 2 isn't like that, you should be in good shape. The next step after this, this is the algorithm. By the way, has anybody ever solved a Rubik's Cube? I know that my kids have. Rubik's Cubes are really tricky, and so like you can just play with Rubik's Cubes to your heart's content, but you may not ever make progress. But if you have one of these algorithms for solving a Rubik's Cube, you'll probably be successful. And since this is a coding camp, being able to implement algorithms is good for us to learn anyway. So the first step in the algorithm is to get tile 1 to location 6. The next step in the algorithm is pretty easy. Move tile 2 into location 5. So I just want to get tile 2 to be right next to it. And this may seem kind of weird at first, but you'll hopefully understand the the reasons behind this, but we're trying to stage these tile 1, 2 because we're trying to like get this top row together. All right, so I've got tile 2 in the middle. Looks like my campers are caught up, so that's good. The next step is we want to kind of slide 1 and 2 around a little bit. So tile 1, you can see, had to go up 1 spot. Tile 2 had to like follow it around. And do that and make sure that tile 3 is not like stuck in the bottom when you do this maneuver. So first I'm going to find tile 3. So it looks like he's way over here, so he's actually in good shape for me. If he was stuck like down here in location 6, I would kind of have to move him out first. But I want to move tile 1 up and tile 2 over, making sure that tile 3 isn't stuck. So you can kind of see how 6 would be stuck in position 9 here, like you couldn't get it out of there. All right, so now I'm ready for the next step. So I want to move tile 3 into the middle. So tile 3 needs to go to that position 5. This step should hopefully be a pretty easy step, presuming it was not stuck. So now I've kind of got 1, 2, 3. They're kind of like a train, right? So this train is ready to move around the station. By the way, if I ever go too fast, just pause the video. That's the advantage of videos. So now with the train ready to move around the bin, you just need to, one by one, march the tiles 1, 2, and 3 around such that tiles 1, 2, and 3 are in locations 1, 2, and 3. So I'm going to go ahead and do that. So I'm just going to kind of march them around. March, 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 march. Now 1, 2, and 3 are all correct. The way this algorithm works is it's very like procedural. And so now we just finished that row. Now we're ready for the next row down. And again, this algorithm would work no matter how big this was. If it was a 4x4, it would work just the same, right? You just have these like 2 rows at a time. So now we're going to try to solve the next row, 4, 5, and 6. And we're going to use the row below it as kind of like a helper. And the first step is to get tile 4 to the lower right corner. This is actually the same kind of thing we did before. So like before, tile 1 started in position 6. And so this kind of like starts in the opposite corner, right? Making sure that tile 5 is not stuck in location 6. So I'm going to make sure tile 5 is way over here, which it is. And I'm going to put 4 in the corner. Great, so I got 4 in the opposite corner of where it's going, and I got 5 not stuck. The next step is to put 5 next to 4. This is very similar to what the thing we did in the row before. So I'm going to put 5 next to 4. Don't even care how it gets there. So now I've got 4 and 5 down here on the bottom. Campers, you got that caught up? And then I'm going to move 4 up and 5 over. So I've got to move 4 up and 5 over. So I've got 4 and 5, like the train's ready to go around. And then I've got to get tile 6 into location 8. So tile 6 into location 8, that was actually pretty easy. And my puzzle is almost done. It looks like gibberish, but it is almost done. Because the last thing I have to do is I have to march tiles 4, 5, and 6 around like a train. And then the neat thing is that 7 and 8 are guaranteed to be correct, which is kind of just neat how it works out, right? So I'm going to march these around. And then you can see that I finished. So see if you can do the algorithm again on your own. I'm not going to walk through it again, but I can hear my camper solving it over there. But the steps, and you can pause them as you need, is to get tile 1 to location 6, making sure that 2's not stuck. Get 1 and 2 together. March 1 and 2 up 1, making sure 3 isn't stuck. Putting 3 on the train wagon, and then marching them around. And then we do the same thing with the next row down. We get 4, which is going to eventually be up here in the corner, making sure 5's not stuck. Get 5 next to 4. Start marching them around. Get 6 in the train, and then you'll solve the puzzle. Sound good? All right, so hopefully you've practiced that algorithm and you're able to implement that algorithm, and you're ready to actually get started today. So what we're going to start with is a choice. And so this choice is, do you want to customize this puzzle, or do you want to just remix one that we give you? I would recommend that you try to customize this puzzle just because it's more fun. So at the end of the day, you'll have like your own image and your own slide puzzle, and you won't just use mine. By the way, these two girls, these are Bob's girls, and so this is Bob Schaefer's family that you're seeing here. But I think it'd be fun if it was actually like your stuff. So what I would recommend you do is option number 1. You find your own image, so something that you want to make into a slide puzzle. Eventually, we're going to need 9 tiles for this image, and we're going to show you the steps for this, where each tile has to be 120 pixels by 120 pixels. It's okay if it's like 119 or 121, but it should be pretty close, right? And I'm going to show you the steps for that. That is what I recommend you do. If you don't think that's going to be fun, you can always click on this remix link, and I'll make this remix link available to you. And what you can do is when you click on this link, there'll be a big button up here that says remix, and you can remix this, but it already has these steps done. So if you have trouble making your own, so that's option 3. Try your best to do option number 1, but then if it fails, do option number 1, right? All right, so let's show you these steps. So the first thing you need to do is you need some website tools. So there's 2 steps in this process. One step is to resize the image such that when it's chopped up, each little tile is 120 by 120, so we need to resize the image. And then the second step is to chop it up. So I've gone on the internet and I found some tools that do these things. So the first tool is Simple Image Resizer. So you can, if you've got the link, you can just click on this link. But if you needed to, you could just do a Google search for Simple Image Resizer. Hopefully the top hit is simpleImageResizer.com, right? And so on this website is where you're going to select your image. So now you need to pick some image. So for me, I've got a lot of different images that I could use. Normally I would just go on to like photos.google.com and I would just like find some recent photo that I've done here. So here's a cool one with Keegan the dog yesterday. Here's some from our recent birthday party. And so you should somehow for you find one of these images. I'll tell you what, I'll just go ahead and click on one of these, make sure my wife looks good in it, and click download. And so I'm going to save this into Fisher birthday. So now I've got my image that I'm using. You should do your own thing to get your image. And then you're going to go into Simple Image Resizer and you're going to say select image. And so mine was called Fisher birthday. And you're going to upload it. Now I was a little fast because I should have known something about this image before I got this far. I should know which dimension is smaller. So in this picture, this is a landscape picture, the smaller dimension is the height. And so whichever dimension is smaller, you need to get that in your head. So for me, it's height. So on this tool, I'm going to say there's a radio for percentage or dimension. I want dimension. And then whichever of your dimensions is smaller, make that one 360. So if you've got a portrait image, make your width 360. If you've got a landscape image like me, so again, this is my landscape image, so the height is smaller. So I want the smaller dimension to be 360. And the reason for that is that way the other dimension is guaranteed to be something bigger, right? Which is good. And then you click on resize. And then you said it's been resized, and then it says click here to download it. So you click on this download button. Now, strangely, it doesn't actually download it. Like, wouldn't you think that a download button would download it? Raise your hand over there, campers, if you think download should download it. Yeah, it doesn't. It opens it in a new tab in Chrome. It does resize it, which is good. But now you need to download it. So I'm going to right-click on it, and I'm going to say Save Image As. And so this got the same name, Fisher birthday, and then it added this X360. So that looks good. So there are a lot of steps in this process, but I do want you to try it. There's a lot of like working with your computer and saving things. So you might get an adult to help you as well. All right, so step number 1, resizing the image is done. It has a height of exactly 360 or a width of exactly 360, and then the other dimension is bigger. The next thing we need to do is we need to chop it up, right? So this is my slides that showed what did with the resize. To chop it up, there's a tool that I found called Postcron, all one word, Postcron. I have no idea what Postcron stands for. Image Splitter. So let's go over into Chrome. and we'll just do a search for post-cron image splitter. Hopefully your first hit is postcron.com/image splitter, and it takes you to this place. And what you need to do is you need to upload that image that you just resized, right? So upload image. Looks like I kind of have to click on it twice. So I have to click on the first one, then I have to click on the second one. And you should have this X360. Now what you're going to do, this is the hardest part, is you're going to make this grid completely fill your image. So here's what I like to do. If you grab it, just kind of like in the middle, you can move it around. We want this grid to be exactly 360 tall. Or 360 wide, just whichever it is. It wants to be a perfect square. If your image is like mine and it's landscape, I'm just going to kind of put it right at the top. So I'm going to place like this upper left-hand corner. If your image is portrait, you're going to have to like slam it over to the side, right? But I'm going to slam mine right to the top. And then to take the other corner and as accurately as you can, make it go right on the very, very bottom. Now this is tricky. You can go short, that's obvious. But you can also go too long. So see how I went too long here and I got these like green things down here. So I want to go exactly on the bottom. And so if you get it perfect, you can see like right now there's little bitty green nubbins out there. You can see how old I am, how I had to get closer to my computer. If you get it absolutely perfect, then you're going to get 120 by 120. If you're off a little bit, you're going to get something close, which will work fine. But I'm going for perfect. Another thing that is annoying is you might have trouble with your picture. So you can see how like Keegan's face and Bowen's face kind of like barely made this feature, right? So if you don't like how it's laying out, pick a different picture. As soon as you're done, you click on split image. And then you click on download image. This time download image really does download image. So I'm going to call this Fisher birthday images. What it's going to give you is a zip file. If you've done a lot with computers, you're probably comfortable with zips. If you're new to computers, you're probably new to zips as well. But what a zip file is it's all your files packaged together really tightly. Now, sorry, there's a lot of steps. This is the easiest method I could find for you, right? So the next thing you need to do is you need to extract all on the zip. So on a Windows computer, you'll have to find it in Finder, and there should hopefully be a button that says extract all. On other computers, you'll just have to double click on it. So on my Mac, I just double click on it. And what it should do is it should chop your image up into 9 tiles. So you can see that I did pretty good. So each of mine is exactly 120. So I nailed it on that previous step where like I was setting the size. It's going to take you a couple of tries. So I nailed mine. I got them all at exactly 120. The order, by the way, is sometimes crazy. So it looks like tile 1 is actually the lower right corner. And then it goes across the bottom for 2, 3, and then 4, 5, 6, and then the top row is going to be 7. Hey, that's a handsome guy. 8 and 9 at the top. It's actually numbered backwards of what I want. We're going to have to deal with that later. All right, so take as long as you need to try to get that figured out. Once you've got your 9 images, then you're ready to get started, right? So it's like we haven't even started yet, Dr. Fisher. You're killing me. So go to scratch.mit.edu, create a new project. So longest setup ever, but it's going to be worth it because it's cool. All right, so I am really hoping that people are successful with their images. I kind of expect that the TA office hours, like you can join the Zoom meeting, is going to just light up today with people that need help with these steps. That's okay. We'll try to make sure there's extra people on board for today. So what I'm going to do is I'm going to actually keep the cat. I know everybody's expecting me to delete the cat right off, but I'm just going to keep the cat. I'm going to go into his costumes, and I'm going to add my images as different costumes. And then eventually, yeah, I'm going to delete the cat costumes. But I'm just going to keep the cat and just come over here and say choose a costume. And I'm going to click on upload costume. Now what I want to do is I want to go into that extracted zip file, which has like my 1, 2, 3, 4, 5, 6, 7, 8, 9. And I want to bring in all 9 as different costumes of the cat. Then what I want to do is I want to delete the cat because I don't really need his images. And so now I've got all these images in here, which is cool. So you should have 9 total. And I'm going to do some organization and cleanup. The first thing I want to do is I want them all to be vectors. So on every single one, I'm going to click on Convert to Vector. So I'm just going to do that first. While I'm doing it, I'm going to explain what I'm doing. So with Scratch, there's 2 different drawing modes. There's bitmap mode and then there's vector mode. Vector mode is the newer mode, and in general you should use the newer mode. But it lets you like add something and then edit it later. Bitmap mode does not let you edit it later, so that's why I like vector mode. The next thing I'm going to do is I'm going to figure out what order my images are in. So mine came in where number 1 is the lower right corner, so it's like 1, 1, and then it's moving across the bottom. I know my image, so this is like the bottom middle, and then this is the bottom left. And then it's the right on the middle row, and then the middle, and then the left. So I know the order that mine come in. And strangely, it's backwards of what I wanted, right? So the upper left-hand corner, in my mind, is location 1. So I've kind of got it on the board here. So I think of this as like number 1, number 2, number 3, 4, 5, 6, 7, 8, 9. So before we get into the code, I'm going to do a couple things. First, I'm going to put a number. I'm going to actually put that number on the image. So the way I do that is I click on text. I decide what color I want to use for my number. It defaults to purple, but you don't have to use purple. You can use any color you want. I'll make mine red, for example. And then I click in here, and then I just type a number 1. Now the nice thing about vector mode is that I can like edit this later and it's not like squished into my picture. So I'm going to get it to right there, which I think is where I want it. Now I numbered this one number 1 because I know my image and I know that this is the upper left-hand corner, and so I put a 1 on it. Now what I'm going to do is I'm going to number all the other pictures. The way I choose to do it is I choose to copy this. I use Control-C, and then I go to my one that's going to be 2. I paste it on there, and then I change the 1 to a 2. But I like to do that because then it shows up in exactly the same position every time. So it takes just a little bit of work to do this. So I go through each and every one. You can pause the video, of course, as you need, but they should be in order, but they might be in backwards order. Strangely, I've tried this on Mac, I've tried it on Windows, I've tried it on Linux, I've tried it on Chromebook. Chromebook comes in a different order than all the others. So that's why we kind of have to do this manually, because yours might have come in a different order, right? All right, so I'm almost done with mine, bottom to top. After I finish the task, I'm going to have to go back and check it just to make sure that it all looks right. All right, so 9 is my lower right corner, and then, oops, so there's 9, 8, 7, 6, 5, 4, 3, 2, 1. Great, so that's important. The next thing that I'm going to change is I'm going to choose to change the name of the costume. So right now mine says 9 up here, but this is really tile 1. Being sneaky, I'm going to copy the word tile to my clipboard with Control-C. Campers, I'll help you do this in a minute. And I'm going to change the names of all of these to a more logical name, right? So this, I'm going to call this image tile 3. I'm going to call this tile 4. And I think you kind of see the pattern. The only one that actually succeeded was tile 5. It's the only one that actually had a reasonable name. And so now the names of all my images match and they're appropriate. And I do that because I'm OCD. That actually has no value at all. Because we're never going to refer to them by their name. We're going to only refer to them by their index. And the index is also backwards. So what I want to do is I want to drag these around. So you can see that this is number 9. It needs to go to the very, very bottom. You probably have to kind of move it in 2 steps. So like you kind of move it about halfway, and then you move it the rest of the way. But I can see that tile 9 is down at the bottom. Tile 1 needs to come to the very top. Probably going to have to do that in 2 steps. Nope, I got it up to where it's in the top. So go back and forth and get your tiles to the correct places. And And so hopefully you'll kind of get a little pattern going and it won't be too bad. But make sure that it actually is in the correct order. So now my tile 1 is at the top. It's called tile 1 and it's got a 1 here. Tile 2, all good. 3, 4, 5, 6, 7, 8, and 9. So pause the video, take as long as you need to do that, and let's definitely save it because that was a lot of work. So this I'm going to call my slide puzzle. All right, I'm going to help my campers out. Hopefully everybody can get this up and running. Expect a lot of questions at the Zoom office hours today. That's okay. All right, so I had to help my campers out a little bit there. That was no surprise, getting their numbers on and getting their tiles renamed and things like that. Again, do keep in mind that if it's going badly for you, you can always remix this project to just use it, right? It already had the numbers in, it already had them rearranged, things like that. Love for you to be able to do your own. If it goes badly, use the remix instead of giving up on the day, right? So that's kind of what I want to say there. All right, so now we're ready to go. So you can leave whichever costume selected you want. It honestly doesn't matter. It's going to show up over here, but that honestly doesn't matter. And we're ready to hop into the code. We're going to be doing code on this one sprite that we have, which is currently called Sprite 1. I don't like that name. I'm going to rename him to Tile. So I just like that name better. So now he's named Tile. And what we're going to do is we're going to do some code on this sprite. And then some code on the backdrop. And just like our previous games, we're going to make use of clones really heavily because we're just going to have this one tile that has different images. It's going to be really creative. By the way, the backdrop, if you want, you can choose to leave it white or you can actually add an image back here. The backdrop doesn't really affect anything. I always kind of like this heart one, right? So I'm going to put a heart back there just because it like shows love, right? Backdrop, completely optional. I choose to stick one on. Let's go ahead and start into the code that's happening on the backdrop. Sometimes I call it a backdrop, sometimes I call it a stage. So our first goal here is going to be very similar to what we did with the lawnmower. So we're going to try to plant all these things so that it forms a grid. So if you remember the lawnmower, the first thing we did with the lawnmower is we did a bunch of math, right? This one, the math is easier. So each of these tiles is exactly 120 across. So this way is 120, and then this way is 120 as well. And it turns out that you're going to need to know where the centers are of each tile. And so if this is 120 and then this is 120, then the distance from here to there is 60. And then the distance from here to there is 60. By the way, it looks like there's a little gap in here, but there's not. They're actually smushed together. So campers, the easiest question of the day, what's 60 plus 60?
120.
120. And then this one's just right at 0. And then this one is down, so it's actually negative 60 plus a negative 60. So what's this one down here?
Negative 120.
Negative 120. And then the math this direction kind of works the same. So you've got a negative 120, a 0, and a positive 120. So the math is actually much easier this time because the centers of these things, it's either at like negative 120, positive 120, or 0, positive 120, but it's always like 0 or 120 or negative 120, so the math is easier. So let's go ahead and see if we can do some of the tricks that we did with the lawnmower on the backdrop. So the first thing we need is we need a couple variables, if you remember how the grass worked. We need a variable, I'm going to call this one the placement X. Interestingly, whenever you're on the backdrop, it doesn't even give you that choice of like, should it be just for this sprite or should it be for all sprites? If you're on the backdrop, it's always for everybody. So I'm going to make a variable called placement X. I'm making another variable called placement Y. And if you remember the trick that we used with lawnmower is we kind of like set these variables to like where it was going to get placed. Then we made a clone and then we moved the clone to that variable. Do you remember that? You remember that, campers? Mm-hmm. All right. So we need a placement X and placement Y, and this time we need one more. We need to know what costume number we need. Costume, I misspelled. Again, you can see that my preferred naming convention for variables that I'm going to hide is this camel case. And so our goal is on the backdrop, let's start by placing just this top one in the corner. And then we'll place the whole row, and then we'll place the whole grid, right? So what I want to do is I want to go to events, when green flag clicked. So no shock, we're going to start with the when green flag clicked. That's how we start like every program. And we're going to set these variables. So I'm going to drag over 3 set commands. And the first one I'm going to set the placement X, and then the placement Y, and then the costume number. So for this very first one, see if you can figure out how you would set these 3 things. So how are you going to set placement X, how are you going to set placement Y, and how are you going to set the costume number? Take a minute and see if you can do it on your own. All right, so my campers actually did pretty good with it. So the X is negative 120, the Y is positive 120, and this is going to be costume number 1. And then what I like to do is I like to, just because we had this problem with the lawnmower, is, I like to make the clone. I need to make that first, right? So create clone of tile. And then I like to have a short delay. I don't know if this short delay is actually necessary this time. It was for the lawnmower. And so I'm just going to stick it on, right? So I'm just going to put a short delay after I place a tile. If I run this code right now, nothing's going to happen because my tile doesn't actually use these variables. So let's go into our tile code and let's actually write a little bit over here. So our tile code is going to be when I start as clone. So we've kind of seen this pattern a few times. That when you're a clone, you don't care about the green flag, you care about when I start as clone. And what he's going to do is he's going to use those variables. So he's got this go to XY, and then he's also got this switch costume to command. So these are the things he's going to do. Oh, and then he's going to also show up after that, right? So remember that with clones, and I can do this now, here's the original. I'm actually going to hide the original, which is very common to do with clones. I'm going to go to where I need to go. I'm going to set my costume, and then I'm going to show. These values are not correct, though. I need to use these variables. So I need to use the placement X. I need to use the placement Y. And then the fun thing about costumes is you can refer to them by name. So you can see I've got names for all mine here. Or you can refer to it by number. And that's the number that you see in this upper left-hand corner here. So it's interesting that the names actually didn't matter at all. So if you went through and you changed them all, then great. But if not, we're not using the names at all. So if I run this, my tile should now show up in the corner, which is cool. These variables are all in the way, so I'm going to hit the green check boxes on these to hide these variables. Also, this is optional. There's the built-in variable called myVariable. If you want to, you can right-click on this and you can delete the myVariable variable. We're going to have enough variables that we don't need the extra clutter today. All right, now from here, you can kind of see that what you could do is you could right-click on this and duplicate it. And you could, just change it to the next one over. So the placement X on this next one over is going to be a 0. And then the costume is going to be 2, right? So if you ran this, it should be pretty easy to put 1 and 2 together. It kind of looks like minor disjoint, but it actually worked. And you could repeat that 9 times, and it would work to place all the grids. Campers, do you think that's what we're going to do? No. No. What are we going to? What are we going to do instead? We're computer scientists. What do you guys think we're going to do?
If, else, repeat.
Yeah, loops and fun things like that. And not only are we going to use loops and things like that, but we're going to use functions as well, because I like functions. So let's start off by going to My Blocks and click on Make a Block. I just like to practice with functions. And so this function is going to be to add a row. So add row is the name of our function. You can see that whenever you make a function, it kind of like gives you a spot to put stuff into the insides of the functions and the ability to call it here. Now I'm going to do a little bit of refactoring. First, I'm going to take off this bottom part that was just kind of like the second tile. That was just kind of show that you could do it. And then I'm going to kind of like pull this one apart a little bit. So some things are going to go into add row and some things are going to stay here. So placement X, that goes into add row, because that's going to be like the X things. It's for a single row. Placement Y, that goes into when the green flag is clicked. Costume number, setting it to 1, that goes into the green flag clicked. And then this stuff is going to go inside of a loop over here. So I kind of took my code and I broke it down some. I happen to know that the X stuff happens like inside of a row, so it's inside of the row area, whereas all these other things are outside of it. So here's what we're going to do. We're going to call add row, and we're going to make it work. How many tiles are there in each row, campers?
3.
3. So we're going to make a loop that repeats how many times?
3.
3 times. You got it. So inside of that loop, we're going to create a clone of the tile. And you'll notice that for the first tile, the placement X and the placement Y are correct. If we just did this loop right now, so if I ran it right now, it's going to be a disaster because it's just going to put number 1, and number 1 all in the same spot, right? So what I'm going to need to do is after I place number 1, I'm going to have to change some of the variables. So let's go into variables. And we're going to have to change the costume number. And we're going to have to change the placement X. So we're going to change the costume number by 1 because it's going to go 1, 2, 3, 4, 5. You get the idea. And we're going to change the placement X. All right, campers, how much are we going to change the placement X by? So from here to get over to the next one?
120.
120, yeah. I was waiting to see if you're going to get it right or if you were going to say 60. Yeah, so we're going to place this one. We're going to move over 120 and we're going to place this one. Going to move over 120 and place this one. So that's going to be the whole row. So if I go ahead and run this, I can see that that whole row just like popped up. All right, so mine came up great. Keegan's actually came up crazy. It's interesting. You know how I said that names of the names of the tiles didn't matter? It turns out that if they're numbers that are numbered different, that does matter. So make sure that if you do have a name for each costume, make sure it's either the matching number or it's something different like tile. So thank you for that, Keegan. All right, so now we got one row done. Now we're going to do many rows. Now we could, as you know, kind of like manually do them. Is that what we're going to do? No way. How many rows are there?
3.
3. So we're going to need a repeat 3. So go ahead and drag over a repeat 3 command. So repeat 3. Oops. Inside the repeat 3, we're going to add row, which is going to be great. If we were to run this right now, it would add 1, 2, 3, and then it would right on top of it put in a 4, 5, 6, and then right on top of that put a 7, 8, 9. So obviously after we add a row, we're going to have to change the placement Y so it comes down. So let's go into variables, change the placement Y. What's the value for placement Y going to need to get changed by?
120.
Oh, not 120. That would go up.
Negative
120. There we go. So negative 120. And so now if this works, it's going to make your whole grid, which I think is pretty cool, right? So it's actually like taking your picture and recombined it. Now, it's funny that in this game, it's like we started with a complete picture, then we chopped it up, and we made it all separate tiles. And then the first thing we did in the code is we put it back together. And then the next thing we're going to do is now we're going to scramble it all up. So we don't actually want it to be in order. We actually want it to be scrambled up. We also don't need tile number 9. And so we're going to go in and make some of those things happen. So the first thing I'm going to do is I'm going to make tile number 9 not show up. So to do that, I'm going to go into and make an if statement. I'm actually going to use this one right here. So this if condition then, and I'm going to have 2 cases. And my condition is going to be, is the costume number 9? So I'm going to find, in operators, I'm going to find the equality one. And I'm curious if the costume number is number 9. So normally, I place it and then I wait for a little bit. But costume number 9 is going to be different. So I'm gonna redo my loop here a little bit. I'm going to say these 2 always happen. So they're kind of like below my if else statement. So they are always going to happen. But this creating a clone is going to only happen if it's not costume number 9. If I put it in the top, that'd be when it is costume 9. So I want to create a clone down here when it's not costume 9. And then now that I've got this whole thing set up, I'm going to put it back inside the repeat loop. Refactoring code is always just a little bit confusing because you have something that looks like this. And if you were able to track what I was doing exactly, you were able to do it at the same time as me. But more important is that you can look at it now and you can see that it's correct. So I've got a repeat 3. I've got an if. I don't have anything up here right now. And then I only create the clone there, but I always change it. If you run it again, it should successfully just leave off tile number 9, which is good. Now, tile number 9 is actually important to us. It's our blank, right? So we need to keep track of where our blank is at all times. Because whenever somebody clicks on a tile, they're going to swap with the blank. So we're going to make a couple of variables. We're going to make a variable called blank x, and then another variable called blank y. I don't need them to show up on the screen, so I'm going to click on this little blue checkbox and hide them. Strangely, I found that if you show them, there can be a bug, so definitely make sure you hide those. And what I'm going to do is in this gap right here, I'm going to set blank x and blank y. So blank x and then blank y. And they're going to get set to whatever the placement x and placement y are. So wherever this tile should have gone in at, we're going to save that off as blank x and blank y, and then we can use that knowledge later in our code, which is going to be cool. All right, now comes some fun stuff. So now, like, you're on day 4 of this camp. The gloves kind of come off against coding. We're going to start doing some crazier things. So what I want to do is I want to shuffle these tiles all around. So here's my plan. I'm going to randomly select a number. And then I'm going to move it into the blank if it's a valid thing to move. And I'm going to do that to shuffle it up. How many times do you guys think we ought to do that just to kind of shuffle it up? Any guesses? 1,000,000 times. So the first guess was 1,000,000 times. So you can go into control and you can bring over a repeat loop. The first guess was 1,000,000 times. That would actually take very long, right? So here's what we're going to do. Bob and I have played with this, and we think that 300 is the perfect number. For testing, though, I'm going to only use 100. So I'm going to do 100 shuffles. And that way it's faster when I'm testing. But before I ship my game, I'm going to change this to 300. Sound good? So this will make testing faster. And then the thing that I'm going to do 100 times is I'm going to randomly pick a costume number. So I'm going to say set costume number, and I'm going to set it to a random number. So I'm going to go into operators, pick random, and the random number that I pick could be 1 through 8. So there's no reason to do number 9 because there is no number 9. So I'm going to randomly pick 1 through 8, and then I'm going to broadcast an event. So I'm going to go into events, and I'm going to say broadcast, and the message I'm going to broadcast, I'm going to make a new message called shuffle. So at this point in the code, there's 8 clones out there. They're all going to listen for shuffle, right? And I'm going to broadcast it 100 times in a row real fast. I'm going to say shuffle, 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 shuffle. You get the idea. And then each tile is going to have a job. They're going to say, was it me that was total shuffle? And then they're going to check to see if they're touching the blank or not. And if they are, they're going to swap. Does that sound good? So let's go from here. So we're broadcasting shuffle 100 times. We're picking a random tile to actually listen to it. So let's go into our tile code. So in our tile code, what we're going to do is we're going to say, when I receive shuffle. So there's 8 clones of this, right? And they all have different costume numbers. The first thing we want to know is this message for me? So we're going to have an if statement. And we're going to decide, is this message for me? And we're going to check that with the equals operator. So he called out a number. So he called out a costume number. And the question is that costume number my costume number? So if it was my costume number, then I need to do something. How do I know if it's my costume number? Well, over in looks, each clone has this variable called costume number. That's perfect. So if the number he called is costume number, if it was me, then I need to do something. The thing I'm going to do, I'm going to put it in a function because I like functions. So let's go ahead and make a function. And we'll call this function try to move. So if we're next to the blank, we will move. If we're not next to the blank, then we won't move. So I'm going to make a function called try to move. So I'm going to call it right here. So if it's my number that he called, then try to move. All right, now let's write try to move. So the first thing try to move has to figure out is they have to figure out if they're next to the blank. So let's look at my board here. So my board doesn't have a tile 9 anymore. It's instead got this blank, and this blank has a value that's right here. So based on the board that I'm looking at here, campers, which tiles can move? So which ones can move into this blank?
6 or 8.
6 and 8, that's right. So they're the only ones that can do it. So the question is, how are they special? And they're special, in my opinion, because their centers are close to this center. And the distance that they are away from this center is they're 120 away from this center. And so what we're going to say is we're going to look at our x compared to his x. We're going to look at our y compared to his y. And if the grand total is less than maybe like 121 or 130, then we know that we can move. McKinley, do you have a question?
What if they're all hers?
What if they're all hers? I keep saying him. So, yeah, I should work on my pronouns. Thank you for keeping me honest there. Now, there's also ones that are like way up here, and this one is too far, right? So here's our plan. We're going to figure out how far we are away. So we're going to do a comparison between the blanks x and y versus my current x position and y position. So these are the variables that are going to be involved in this. And what we want to do is we want to know the delta between the x's and the delta between the y's. So to get a delta, that's subtraction. So I'm going to grab a subtraction symbol here and a subtraction symbol here. So I'm going to say blank x minus x position. Blank y minus y position. So this is going to give me the delta x or the delta y. Now, it might be a positive number, it might be a negative number, and I don't care if it's positive or negative, I always want a positive. Do you guys know what function will make something always be a positive? All right, I think Keegan's got it.
Absolute value.
Absolute value, that's right. I took a little coaxing here, but it's called an absolute value. So Scratch has this thing, it's like can do all kinds of crazy math things, but the one we want is ABS, because it stands for absolute value. You may have never seen absolute value in school yet, but believe me, you will, right? So I want the absolute value of the delta x and the absolute value of the delta y. Now what I'm going to choose to do is I'm going to choose to add these two together. So to add them, I need the plus operator. Make sure that you get the plus operator. When I prepped this, I grabbed the multiplication operator. Trust me, that did not work, right? So I need the plus operator, and I'm just going to add these two together. By the way, whenever your operators kind of get complex, make sure you always grab it from the middle. So this one, the middle is the of. So I'm going to drop this into 1/2. And then I'm going to grab the of here and drop this into the other half. And now for this big one, if I want to move it, I have to make sure I grab the plus, right? So we're not done yet. What we want to do is we want to see if this whole thing is less than, I'm going to use a threshold of 130, right? And the 130 will make sure to pick off everybody, including the diagonal. But that'll give you a little flexibility in case your images are a little too big, right? So I'm going to say if this whole thing is less than 130, so I'm going to go ahead and grab a less than and 130. So if this whole thing, so I've got to grab it from the plus here and drop it into there. It's so big it doesn't even fit on the screen anymore, right? So if that whole thing is less than 130, then I must be next to the blank. And this algorithm will work even if the blank's in the middle, then it'll figure out that these four can move, right? So it's kind of a smart algorithm. So now what happens if we are a match? If we're a match, we've got to swap with the blank. Swapping is a very popular thing that happens in computer science. So let's see here. So let's say I had two variables. I had A is 5 and B is 7. If I wanted to swap them, I could say that A is equal to B and B is equal to A. Campers, would this work in code? No. So this is an interesting problem that happens in code. Let's step through what happens just because I like it. So this is the values of A and B, like as this code executes. So right here, A is 5. After this line, A is still 5, of course, but now B is 7. After this line of code runs, it says B is equal to A. So it actually reassigns A. So A is now 7, but B is still 7. And then this line does nothing. So this direct change, A is B and B is A, doesn't work, which is interesting because of how sequential programming works. And the trick to fix this problem is you need a temporary variable. So I'm going to call it T. So I'm going to save off the value of A into this variable T. It's a temporary variable. Now I can blow away A, and then at the bottom here I just have to use T. And this trick does work. If I were to put T over here, we'd have like 5, 7, and 5. And then we blow away A. And then we set B to that temporary variable. And then interestingly, at the end of the day, we don't care about that temporary variable. So it's a very common thing in computer science where you want to swap two things, and you can't just swap them like you would think. You have to make a temporary variable. All right, let's just do it, right? So we want to swap my position with the blank's position, so that's our goal. And we're going to have to make a temporary variable, which we just learned about. So let's go and make two variables. We'll call one temp x, and then the other one is going to be temp y. So we need a temporary variable for the x and temporary variable for the y. I don't want to show them, so I'm going to hide them. And now I'm going to do a bunch of steps. So the first thing I'm going to do is I'm going to set my temporary variables. So I'm going to say temp x and temp y. And the thing that I'm going to choose to save off is I'm going to choose to save off the x position and y position. So I'm going to save off x position and y position. So the nice thing is that once I save them off into a temporary variable, then I can blow them away, right? So like I can change them. The fastest way to change them is this command. It says go to xy. Interestingly, you could also set them individually with this like set x and set y, but we'll just kind of do it all in one shot. And the thing we're going to set them to is we're going to move this tile to wherever the blank is at. Does that make sense? So this tile is going to move, and it's going to move to wherever the blank was at. And then the blank is going to be where this tile was. So they swapped. It's called a swap, right? So now I need to set blank x and blank y to those temporary variables, temp x and temp y. I can't set them to x and y anymore because those have been changed by this blue line, right? But I can use those temporary variables. So it's kind of a fun, crazy thing. So I'm going to pause it and ask my campers if they understand this code because it's kind of complex, right? So make sure you can look at this and explain what's going on. All right, well, I should see if this works. So when I click this green flag, what should happen is it should shuffle them 100 times. And so it happens kind of quick, and it shuffles them around. You'll notice that they're not shuffled great. They're shuffled good enough for testing. Eventually, we're going to change this number to be 300, which I think will shuffle them a little bit better. So like you can see before, my number 1 was still in the upper left. But with 300, it shuffles them a little better. I think that one shuffled enough. But I'm going to actually leave it at 100 for my testing. That way it's faster. And then as soon as I finish my game, I'll put it back to 300. Does that sound good? By the way, it's also good to take breaks every so often. So as soon as you see that this works, maybe take a break, right? So just take a break, pause the video, walk away, and come back a little bit later. All right, are you back from your break? Let's do some more stuff. So the next thing that I think really needs to happen is I want to be able to click on a tile and have it glide into position, right? So I want it to kind of glide over. So let's see if we can implement that. And to be honest, that's actually one of the last required things for today. My campers are going to have to do the whole thing. But after this step, you could be done after today because it is pretty big. So let's make it to where when you click on one of these, it'll glide into position really nicely. So here's what I want to do. I want to go into my tile code. And you can see that my tile code already has like a when I receive shuffle, When I start as clone, so it's kind of got all these things. And we're going to make something else. We're going to get an event called when the sprite is clicked. So when the sprite is clicked, what do we want to do? So what we're going to do is actually similar in many ways to shuffle, because we're going to try to move. That's going to be our main thing. We don't have to check if we were the ones clicked. We know we were the ones clicked. And so like when this tile is clicked, we want to try to move. Let's go ahead and try it with just that additional code. So it does my shuffling. And so now, oh, I had this goof. This sometimes happens. I've got a goof to where I've got 2 holes. I'm going to pretend like I didn't see that and just run it again. So you can do the same if that ever happens to you. So right now what should happen is if I click on 7, it should try to move. 1 should try to move and it should work. But if I click on like 4, it shouldn't do anything, right? Only the ones that are next to the tile can move. So I think that that actually is doing pretty well. It looks like I can play the game if I wanted right now. I could use my algorithm to try to solve it. I'm not going to right now, but I could, right? So I could actually like try to solve this thing. Instead, what I want to do is when I click it, I want it to smoothly glide, right? So you can see that right now it's just going there. It's just snapping over. I think it would be cool to have had kind of like a slide animation. So how do we do that? So the first thing we need to do is this go block in here needs to have an if statement around it. So here's what I'm going to do. I'm going to go into control and I'm going to grab an if else. So sometimes I want to get there like immediately, and then other times I want to glide. So I'm going to go ahead and break this up a little bit. And I want just this blue line in here, and then I want to put that on the top, sorry, that on the bottom, that on the top, so this refactoring thing again, and this is going to be in this area. I'm going to kind of put it all back in. So I'm still going to do the swap, so same thing as before. It's just instead of a go to, I'm going to use a different command called glide to XY. So sometimes I'm going to go there, and sometimes I'm going to glide there. Now, operator or variables here, I'm going to move in blank X and blank Y. And this glide, I'm going to glide in 0.2 seconds. So sometimes I want to go, sometimes I want to glide. How am I going to decide whether it should be a go or a glide? So what I want to do is I want to pass into this function an argument. This is something new. So right click, so your right mouse button, right click on this word define and click on edit. And what I want to do is I don't just want to have a function, I want to add an input. I'm going to add this number or text. So I'm going to click right here. And I'm going to give this argument a name. I'm going to call it go or glide. And you can make it say like go or glide like this. But what we're going to do is go is going to be a 1. So I'm going to say like go 1 or glide 2. So I'm going to call it go 1 or glide 2. So they're going to pass in a 1 or a 2. 1 for go, 2 for glide. And so now you can see that it says up here, try to move, go or glide right there. And then when I call it, you can see that it added this thing. So this, when I'm shuffling, it's a go. So go is 1. And then when I click it, it's a glide. So glide is 2. So go 1, glide 2. Now I need to use that variable in here. So I'm going to go to operators and grab an equals. So where's my equals operator? So if, and then this is tricky, you actually grab it from here and put it down there, which is, I think that's kind of tricky how you just kind of do it from right inside here. So if go or glide is a 1, then we want to go there. That way shuffling is fast, right? But if it's a click, we want to glide there. So let's try it. So right now I shuffle and it's fast. It did the 2 blank thing. I'm going to pretend like I didn't see that. Moving on. So now whenever I click it, things should glide to the correct position, which is cool. And now what we're going to do is we're going to give you the option of adding the extra features or not. So you can see that right now the game is completely playable and you can win it, which is cool. If you would like to be done right here today, you could be. Pat yourself on the back, go do something else, call it done. If you wanted to, though, we've got some extra features for you. So, for example, it feels unsatisfying that you win and nothing happens, right? And so it'd be nice to add that feature. It also would be neat to add kind of like a moves counter so you know how long it took you to do it. And so those added features is what we're going to add next. And it is just a little bit complicated, so if you feel like calling it a day, great job. We'll see you tomorrow for the final day of coding camp. If you've got the energy to do these last things, then let's go ahead and do them together. So what I want to do first is I want to check to see if we solve the puzzle or not. So how do we check to see if we solve the puzzle? Well, each tile needs to know if it's in the correct position or not. And to do this, we're going to use something called an array. An array is new. So if you go into variables, in the past we've used all kinds of variables. We've made a fair number of blocks as well. But see where it says make a list. So here's what we're going to do. Each of these tiles has a certain X position it's supposed to be in. So this is supposed to be at -120, 0, and then +120. They also have a specific Y they're supposed to be in. This top row, the Y is always 120. And so we're going to make a list of what the correct X's and correct Y's are. So go ahead and do this with me. Go into your backdrop, because that's where we're going to be putting the code. Click on Make a List. So this list is going to be the correct X. I could say correct X values, but it's going to be correct X. So this is going to be a list of correct X values, and it's going to have the values like -120, 0, +120, -120, 0, +120, -120, 0, +120. So it's going to have 9 values total. So those are the correct X list values. And you can see it shows up on the screen. We're going to eventually hide it, but let's go ahead and leave it for now. And then we're going to make another one. This is probably no surprise, called correct Y. And it's going to have a list with 9 items, and it's going to be 120, 120, 120, 0, 0, 0, -120, -120, -120. So those are going to be the values. So we have to make this list. The easiest way to make this list is to cleverly put into your code where you should clear the array and where you should put things in. So we're going to clear the arrays at the very start. So to clear the arrays, we're just going to say delete all of correct X, delete all of correct Y. And so that's going to make sure that they start empty. So right now they're empty, but we're going to guarantee they start empty. And then we're going to add things at very appropriate points. So let's do this. I'm going to drag over add thing to correct X, and I'm going to put it inside my add row function, inside the repeat 3 loop, just before the if statement. So you can see where it's at there. And so what I'm going to do is I'm going to add placement X to the correct X list, and I'm going to add placement Y to the correct Y list. And so my goal here is that these two lists that you see, which are currently empty, they're going to get filled in with the what are the solution locations. So when I run it, it'll still do like the other things in the background. But the thing I care about is that this filled in with a -120, 0, 120, -120, 0, 120. You can see the pattern. And then this one's like the 120s, the zeros, and the -120s. So we know where things should be. Now I'm going to hide them. Now what I want to do is once I do a glide, so I'm going to go over to my tile. Whenever I do a glide, I'm going to have people count themselves. So I'm going to say, hey, how many tiles are correct? So I'm going to broadcast out that everybody should count themselves. And I'm going to make a variable that keeps track of how many are correct. So let's do it, then it'll make more sense. First, click on Make a Variable. This variable is going to be num correct. Again, there's lots of different ways to do variables. I choose to use camel case, smush them together. Instead of spelling out the word number, I just type num correct. So I've got that variable. And whenever I glide, I'm going to set it to 0. So after a glide, I'm going to set num correct to 0. And then I'm going to broadcast that everybody needs to count themselves. So I'm going to broadcast a message that says like check for win. So everybody's going to count themselves. We're going to see how many of us are correct. And if there's 8 correct, then that means that we've won the game. So let's go ahead and keep going, but I'm going to check in on my campers first before I do this next step. So I checked in on my campers, and Keegan was no longer at his computer. Keegan, are you calling it done for today?
Yeah.
Yep. So he was happy with the previous stuff. What about you, sis?
I'm adding the extra features.
Yeah, she's going strong and adding the extra features, and that did not surprise me at all, knowing my kiddos. But I did want to point out that it is okay that if you chose to stop. So I've got num correct set to 0, and then I broadcast check for win. So the idea is I'm just screaming, hey, everybody, see if you're in the right spot. And then we're going to see how many of us are in the right spot. So down here, we're going to have to say, when I receive, check for win. So all tiles do this. They have to see if they're in the right spot. And so what we need to do is we need to compare our current X and Y. So we're going to compare our current X and Y to the correct X and Y. So I'm going to go into variables. I just like to get the things that I need, right? So I need item 1 of correct X and item 1 of correct Y. Now, this is a list, right? There's 9 different items in there. I don't always want number 1. I want the appropriate one for my costume number. So like if I'm costume 4, I want to compare against the 4th item in the array. So I don't want a 1 here. I want to actually go into looks, and I want my costume number. So costume number. So if my X is equal to the correct X for my costume number, and my Y is equal to the correct Y for my costume number, then and only then I can add 1 to the number correct. So I'm going to need some operators here, so I'm going to have to check these for equality. So I'm going to go ahead and grab an equality here and equality here. So I'm going to say if my X is equal to this, and my Y is equal to that. So if that is true and that is true, so I need an AND statement now. Again, these things get really complex, right? So you got to grab it from like the middle of it. So big I can barely even see it. And I've got to zoom out some just to see my whole thing. So if my X is equal to the correct X and my Y is equal to the correct Y, then I can do something. So I need an if statement. So I got to grab it from the AND. Then what I'm going to do is I'm going to report that I was correct. And the way that I report that I was correct is I go to variables and I change the number correct, so num correct by 1. So you can see that somebody did a glide, he reset it to 0, and then he told everybody to count themselves. So let's go ahead and see if this is working. So if I run it now, it does some shuffling. If I get my 2 blank thing, I just click it again. And so as soon as I do a glide, so I'm going to glide the 5 tile over, everybody should count themselves. And so if we look at mine, we can see that 1, 2, and 3 are all wrong. 4, 5 is correct right here. And then 6, 7, and 8 are all wrong. Let's go ahead and do another one. I'm going to put 4 is in the correct position. And now 7 is in the correct position. And now as soon as I slide 8 over, it should go up to 3. So test it however you want. But the number correct should be getting tracked now. If you wanted to solve the whole puzzle, you could, but that, of course, takes a little bit of time. I'm going to go ahead and solve mine just for fun. I've done these algorithms enough that I can usually get them done in a timely fashion, right? So I'm going to go ahead and click here. And so right there, it should be 8. So there, num correct is equal to 8. Nothing happened when num correct was equal to 8 because I haven't written that code yet, right? So it's all about writing the code to make these things happen. McKinley, are you caught up or did you fall behind?
I'm caught up.
So she's good. So we're still going strong. So who's going to check to see if we're correct? It could actually be about anybody. I'm going to choose for the backdrop to check if I'm correct. And just because I can, I'm going to actually just make another when green flag clicked over here. When this green flag is clicked, I'm going to make sure that my num correct variable is set to 0. So I'm going to say set num correct equal to 0. This is because like when the last game finishes, if it was 8 when the last one finishes, I want to make sure to clear that off. And I want to forever check if the number correct is equal to 8. So I want to check if it's equal to 8. I did that really fast, but it's because I think that you're kind of getting to the point where you can do some of these things, right? So I'm not just checking once. It's not a single if statement. I'm just forever checking to see if the number correct is equal to 8. If it is, then I've won the game, right? And when I win the game, I want to do a couple of things. One is I need to play a sound. That's probably the most important. I think the sound I'm going to play is cheer. So I have to add cheer to my library. So it's kind of loud, but cheer worked. So I added that to my sounds like we've done before, and then I'm going to play it over here. So I'm going to play it until it's done. So I'm going to play cheer. I'm also going to bring in the 9th tile. So if you remember when we started this lecture like an hour ago, the way we bring in a tile is we set 3 things. We set the placement X, the placement Y, and the costume number. And then we create a clone, which is in control. Again, I brought those in kind of fast. It's because only like the true troopers have made it this far, right? And what I want to set the placement X and placement Y to and the costume number is, well, the costume number is going to be 9 because that's going to be where it's at. And then I want this spot right here. This spot right here is actually saved off in the variables blank X and blank Y. By the way, I don't really need to show that number correct, so I'm going to hit this green checkbox to get rid of it. So when I win, I want to load in the 9th tile. So I set placement X and placement Y. I set the costume number. I say create clone, and that'll actually bring him in. And then I want to play a sound. And then I'm going to wait for a minute, or wait for a few seconds, maybe like 2 or 3 seconds. And then I'm going to stop all. And I'm just waiting for 2 or 3 seconds just so you can enjoy the victory while you're there. Bob likes for this number to be like a full minute, so he does like 60 seconds, whatever you want. I'm just going to do 3 seconds because that'll be plenty. And I think I'm ready to give it a go. Now, I will say that in order to test this, I do have to like get them all right to test it. So if it fails, I'm going to like really regret how hard it was to test. If you want to test it easier, change this number 8 to like 2 or something like that. I think that I can do the whole thing. So I'm going to go ahead and just try it. All right, so I'm almost there. So as soon as I slide this up, I should be able to see my victory sequence. So I slide it up. It all worked great. And then after my 3 seconds, it goes away. So I'm going to help my camper out. Oh man, I just learned something great from McKinley. So a great way to test this is to shuffle it less. So where it says like repeat 100 or something over here, just shuffle it like 3 or 4 times and then play your game. And now it's actually like super easy to win. Sissy, brilliant. Nicely done. So I think that mine is going pretty good. I'm going to crank this up to 300 now. If it didn't work, you're just going to have to look at the code that we did recently, rewind the video. Sissy had a goof here on correct Y that we fixed. But I think that we're ready for the last thing, which is to track how many moves we've got. So I'm going to go into variables. I'm going to make my final variable called moves. I'm going to set moves to be 0 somewhere. Again, I don't really care where you set it to 0. I'll tell you what, I've just been goofing around over here, so I'll go ahead and do this. I'm going to say set moves to 0. Moves, actually, I'm going to click on it here, or sorry, right click on it and say large readout, just so it's funny that large readout is smaller. I find that funny. But every time I move, so every time I glide a tile, I'm going to increment moves by 1. So I'm going to change. So every time I do a glide, I'm going to change moves by 1. Now, if it works, McKinley, you got a question?
I got messed up somewhere again.
All right, so I went a little too fast, so I'm going to go back and help McKinley. I'll tell you what, I'll just say what I said. So I created a variable called moves. I set moves to be 0 somewhere in the code. I chose to set it to be 0 on the stage right after a green flag check, so that just sets it to 0. And then I increment it when I do a glide. And so the glide happens inside the tile. Right after a glide, then I change moves by 1. And so now as I move, it should just keep track of how many moves that I've got. That fix you up, Sissy?
Yep.
So now it's going to like keep track of how long I take to do this algorithm, which can sometimes be quick and it sometimes can be disastrous. So I'm going to go ahead and see if I can finish mine and see what it is. You could also choose to add like a fastest time or something like that. But hey, you know what? That's up to you. I would recommend that you click on share. And so if you share it, then other people can visit it. Looks like it took them just a minute to share there. And then this URL you can send to friends and family, and you can see how things work. I suppose I ought to see one last time how long it takes to do my algorithm here. All right, so I think I've got mine to where it's almost solved, and so I put it together, and mine works. What about my campers? So campers, let's see how you did. So Keegan obviously isn't going to have the win thing in his because he chose the to finish when I said it was fine. Oh, look at that picture. It's him and his dog Doovie. Excellent, very nice. I love the picture. So if you ever want to do the win thing, I can always do it with you later, okay? Very nice, Keegan. Did you enjoy today's?
Yeah.
Did you like the slide puzzle? Was it a little more complicated than anything we've ever done before? All right, McKinley, let's see yours. Oh, she's got all these cool horses we found in Scotland. Very nice, very nice. That's cool. Did you learn some new things today, sis?
Yeah.
Yeah, today was crazy. All right, so I want to say a couple things, and then we'll turn you loose. So the final things that I want to say today are that you've done a lot of crazy things with clones now. You learned how to use arrays. And with code, you can do a lot more than you think, right? So like a complex puzzle like this is totally something that Scratch can handle, and it's really kind of cool. All right, go share your link with friends and family. Let them try their puzzle. Don't tell them the algorithm, right? Just make them try to figure it out. And then you can use the algorithm and show off your skills. All right, loved having you. Can't wait to see you tomorrow for the final day of our coding camp. See you then. Bye.